We're going to take a look at searching and sorting algorithms. We'll call this section the Introduction to Search Algorithms. A search algorithm is a method of locating a specific item in a large collection of data. This could be an array or a vector. We previously talked about these in the previous videos, which are in the playlist link below the like button. This section is going to discuss two algorithms for searching the contents of an array. Two ways of searching an array are the following. You have a linear search as well as a binary search. For a linear search, the elements don't have to be in order. For a binary search, they do. Since I'm going to be using the same vector for both examples, I have it in order, but again, for linear search, it does not have to be in order. Collections could be arrays, array lists, linked lists, vectors, whatever have you. There's tons of different ways to have collections of data. So far we've gone over arrays and vectors, so I'm just going to be using vectors here. Linear searches are also known as sequential searches. It sequentially steps through an array or vector, examining every element until it locates the value that it's searching for. I have a great example here where we're actually going to be able to enter a number that we want to search, and we can see how long it takes for the linear search to do it versus the binary search. So if we use a linear search, it's going to look through every element in this array until it finds the value, then we'll be finished with it. So let's look at the method that I have. You can see I have these function prototypes up here, which allows me to code the method down here. So we have the linear search method. It's going to be void because I'm just printing, and it's going to take our vector as an argument. I'm setting our boolean to false, and this is just to say if it's not found, I'm just going to print not found at the end. That's all that's there for. If it is found in here though, we just set our boolean to true, and it will never return not found because it's found. So we're going to take a user response, we're going to store it in response, and that is going to be the number that we're searching for. So you can see in this header, we're running it for our entire vector size, and this line is just going to be printing out the indexes until we reach the index at which our element is. So let's search for, I think the highest in here is 10. Let's search for 10. And you can see that it's going to take 10 times to locate it using linear search. That's a lot of times. Now, if our collection of data is in order, we can use the binary search. Array elements must be in order, and what it does is it divides an array or collection into three sections. You have a left element, a middle element, and a right element. Before I show you the method for it, let's search 10 in here. And you can see it only takes 4 times to find this and then print out our found. If we look in our binary search method, you can see there's a lot more code that has to go on here. However, what it has to go through is a lot less. Typically, this is the case. You either have less code and it has to do more iteration, or you have a lot more code and it has to do less iteration. Now, I have this cout not found. So let's look at how a binary search works. So we still take our vector as an argument. This is just taking the user's response. This is the same thing as last time. We need to initially declare and initialize our left and right. The left is just going to be the lowest, which is 0, and then our right is going to be the total size of our vector. Now we're going to want to run this as long as our left is less than or equal to our right. Either our left is going to get bigger or our right is going to get smaller. If there's nothing in here, they're eventually going to equal each other, and we'll go out of the while loop and then hit this not found. If we do find it, we're just going to return found it. So we don't need to worry about Boolean in this case because it's a while loop. This is our middle. We're just basically finding the middle. So if you take the left and the right, so if you have like 0 and 12, well, you'll have 12 divided by 2, the middle is 6. So this is how we would get the middle here. And then we're just going to basically print what we're looking at. First it was 5, then it was 8, 9, and 10. If our current middle is equal to the response, which is our user's response, we are going to want to print found it, return, we're done. Otherwise, we're gonna have to do some updating. So if our response is less than the middle value, that means whatever the user typed in is to the left of the middle, meaning that we should update our farthest right value to the middle -1 because it wasn't the previous middle, so we don't need to look at that middle. So middle -1. Otherwise, if our mid is less than the response, meaning the response is on the right hand side of our middle, well, we should update our lowest left to the middle but +1. And then we'll either eventually find it or we eventually won't. You can see how much better it is to use a binary search versus a linear search if you have a sorted list. And that'll be it to our introduction on sorting algorithms. If you have any questions, as always, please leave a comment below. And if you want more C++ practice, check that playlist below the like button.